Welcome to today's webinar on why Excel fails requirements in test management. My name is Nick Exposito, Marketing Director here at TriStar, and I'm very pleased to introduce our presenters, Robert Leslie and Laura Estee. Before we get started, I just wanted to do some quick bookkeeping and mention that a complimentary recording of this webinar will be sent to everyone who registered and will be available on our website and YouTube channel at TriStar PLM shortly after the presentation. We'll also try to leave some questions at the end. In the upper right-hand corner, there's a question box, so feel free to use that to type in your questions, and we'll try to leave enough time for a little Q&A. So without further ado, I turn it over to Robert and Laura.
Thank you very much. It's wonderful to meet everybody here today. We're delighted to go through kind of some challenges and concerns we've heard from some of the customers we've spoken with. As mentioned, my name is Robert Leslie. I'm part of the team at PTC, and I'm joined here today by Laura. Laura, I'll let you introduce yourself.
Hello, I'm Laura Estee. I'm a solution consultant here at PTC, specializing in ALM and Codebeamer.
Awesome. So let's get started. For the webinar today, we thought we'd go through and we'd talk through some of the obstacles that we've heard in the years we've been talking to engineering companies, where today requirements and tests and risks are all managed in a document-centric manner. So by that we mean lots of Word documents, lots of Excel documents. We might be using Confluence as well, Google Docs. There's all sorts of document-based systems that can help manage this. And to start with, let's address the elephant in the room. This is a method that can work. If your products are simple, if you're not changing things very often, this can get the job done. It's when things start to scale. It's when you start seeing complexity in your products. It's when you start seeing the introduction of new products becoming a concern. It's when you start caring about MPI time, you start caring about efficiency, and you start caring about quality and compliance. That's when the structure starts to hold the organization back. And those are the pinch points we'd like to talk through. We'd like to share things we've heard, and we'd like to show you our tool to address these concerns, to show you a way of working that can help manage this. When we talk to interesting manufacturing companies, we hear consistent themes about the pressures they're facing today because of the market. We're hearing a need for faster innovation. The market is now truly global. You're competing with large, innovative companies around the world. And so you have to innovate faster to keep up. We're seeing a lot of pressure for efficiency. The uncertainties around the global trade environment, the uncertainties around the domestic economy, all these things are weighing in for a need for increased efficiency in organizations. The companies that are thriving are able to operate with agility and resiliency. And what that means is they're able to make good decisions quickly. They aren't victims of analysis paralysis, and they have resiliency in their operations. We're seeing an increased focus on quality and regulatory. The regulatory environment is changing. We see a lot of drive if you're a medical device company, an automotive company, or if you're just a good old-fashioned ISO 9000. There's a lot of new laws coming in place around privacy, around consumer rights, consumer protections, around environmental. It's all driving change and a lot of issues for organizations. And lastly, we're seeing an evolving workforce. And that doesn't necessarily just mean the aging of the workforce, the need to replace people. That also means a drive for people working from home. That means a more geographically distributed working team and changes for people's expectations for how they're going to work. So as we engage with companies, we hear this common theme. There's really three things that everybody's trying to do. Everyone is trying to accelerate how quickly products are introduced. That means leaning more on software-based innovation. It means using more software tools to help drive. We're looking to diversify the product line to create a broader suite of offerings. And we're looking to do circular product offerings, right? We're trying to both We're trying to harness more of the post-sale service revenue. We're trying to create more post-sale operations and offerings for our customers. And we're trying to capture the information after the product gets into the customer's hands so we can make better engineering decisions as we move forward. We're also hearing a lot of pressure for increased efficiency. We talk to VPs of engineering and corporate executives. We're hearing a constant need. How do I reduce the amount of cost it takes me to bring something to market? How do I reduce my cost to suppliers? How do I design things so that they're better suited for manufacturing and also designed for serviceability? And how do I collaborate across a global team? These are not easy challenges. And when you're looking at using tools like documents, we'll go into this, but these challenges multiply. You should think of these as multiplicative, not additive challenges. And of course, everybody's dealing with that baseline of quality and compliance. You have to get your product right, right? With how competitive the industrial marketplace is now, you have no choice. You have to get it right. You have to get the good product into the customer's hands. And you have to be constantly improving your operations. But how do you do this, right? These are not easy concerns. So as we start talking about how do I build a product? How do I manage my requirements? And how do I manage the testing I do to satisfy that? Well, as products become more complicated, right? We see the different disciplines that get involved as people are building out their products. Here we have some examples, right? We've got a mechanical engineering practice, an electrical engineering practice. We might have some software engineers. Depending on what vertical you're working in, you might have other engineering disciplines, chemical engineers, biomedical engineers, different sorts of engineering, maybe mining engineering. And then we've got our suppliers and our outsourcing. What we see with Excel and Word document-based requirements management is each of these teams are going to have their own sets of documents. Each of these groups are going to develop their own tribal knowledge over what they're trying to build and how they measure what they're doing. It also means, if you think about it, right, for each product we're doing, we set out a set of documents that say, here's what we're trying to do, and here's how we measure what we're doing to get there. And we give those to the teams, and the teams all then take that and make their own documents. So we now start having this fractal problem where we have documents that create documents. Nobody can see each other's documents. Everything is creating natural data silos. And we have kind of tribal ways of working emerging in addition to tribal knowledge. So each team, because they're working from documents, they're all going to start working in their own peculiar ways. They all have their own tools. The mech engineer is going to eventually move into the CAD world to design the physical parts. The electrical engineers are going to get into their ECAD tools to design the circuitry. And the software people are going to get into tools like Jira and GitHub to write the code. The suppliers that, again, like when you're trying to work across these teams, when you're trying to manage what it is you're trying to build through documents, you have no visibility, you have no resiliency, and it makes decision making very difficult. So we think about how do we address this, right? Like how do we make us more efficient? How do we make us get to market fast? How do we address quality concerns? We see three common themes for this. The first is to be able to provide orchestration across all the teams. That means being able to not like have to hop between documents, right? And say, okay, I need to understand where all the teams are. It it doesn't matter if you're a medical device company. It doesn't matter if you're a company that makes wrenches. Knowing where people are in the design process should not involve getting everybody together in a meeting and asking people what's going on. You should just be able to look at what your tools tell you and be able to see how the new product is coming along and where the pinch points are. We see an increasing need, a lot of executives talking about the need to collaborate across teams. When mechanical engineering makes a design decision, that impacts the electrical team. And when the electrical team makes a design decision, that impacts the software team. Similarly, walking back in the other direction, the software team might need to do a feature differently than they originally thought, which requires changes in the electrical and mechanical groups. And so, if we're all operating on our own silos, how do we know something has changed? It's a non trivial problem, right? And it draws from the lack of a common data foundation. So, again, because we're all in our own little documents, and when I say little documents, some of these documents can be hundreds of pages long. When we think about how this problem nests, let's take, for example, an interesting kind of organization, the US Army. The US Army has, as you break out the various levels of organization, around 25,000 different units of organization as you look at squads and move all the way up to combined armies. If we have a PowerPoint deck, this is a good illustration of this point. If we have a standard PowerPoint training, like your Friday afternoon training before you send the soldiers home for the weekend, right? Don't drive drunk, don't get in fights, get into trouble. Now, if we change something about that training, and we're giving that training at every level of the organization, we need to go in and edit 25,000 plus PowerPoint decks. And this is a problem that emerges too when we have document-based requirements management. We need to go in, if something changes for the organization, if we have 10 products, we have to go and find all those copies of that document and change them. How long does that take and how much does that slow down operations? It's a big challenge. And it prevents us from working really in the engineering V model. Where in the engineering V model, we need to actually be able to trace from user needs down to the detailed design and then up from verification through overall product validation. And if we think about each of these items being a disconnected document, which is often what we see with document-based ways of working, we might create a trace between the user need document, a requirement there, and the system requirements from the systems engineers. But that trace is probably just going to be a reference from a document section to a document section. It's not going to tell us anything when something has changed. It's not going to be immutable. And it's going to require manual revision if we need to change something or add something in the future. When we put this in the context of an actual product, it gets even crazier, right? Because we're not just dealing with one set of requirements and one set of detailed designs. We're also dealing with information going into multiple systems. Here, for example, we've got some PTC logos, but you can imagine we have a set of customer requirements. The requirements engineers set out a bunch of system requirements. The systems engineers design the architecture of what exactly we're building. And then we give it to those engineering teams who were looking at previously. And what that causes is, again, this crazy network of documents that breaks out. So we end up with people working completely siloed. They have no idea what the other teams are doing. And when something changes, it is hard to find out what changed and how and what the impact of that change is. It also means to zero in on the software group, for example. If we don't have some real systemic approach to traceability, if we get a problem, if we get a complaint, it's really hard to trace what is actually driving that complaint and then to fix it. I spoke to a medical device company and they told me it takes 30 working days. If they get a customer complaint that requires a update to the software to resolve, they need 30 working days to track down the source code that is causing the issue. That's before we fix it. We have wasted a whole month of time. This is something that has real dollar value associated with it, and it has real quality issues that associate with it. As we think through, what is the impact that this has on teams and their ability to make good decisions? If we don't have a common set of requirements, if everybody is working in their own various documents, then we have no common architecture because we don't have an actual overall view of what's going on. If we don't have an overall view of the architecture, then we can't really be aligned on the decisions that we're making. And if we're all working in silos, then we have no idea where the milestones and deliveries are without getting everybody together in a room for a very expensive meeting to try to figure this out. It also means if we're all working in our own individual documents across the various teams, we don't really have a good way of communicating updates and changes, right? If something changes, how do you know something changed as an individual contributor? If you don't hear it at the meeting, you miss it. That drives incomplete tasks and changes, right? When something needs to change, how do you have visibility? How do you have accountability? You find out when the product's late. This leads to late stage problem identification, and we want to help you identify problems earlier. The earlier you identify a problem, the cheaper it is. This leads to regulatory compliance, the worst kind of problems to have, right? When a regulator starts knocking on your door, not in a friendly way, but saying, hey, we have an issue, right? That's a problem. The testing group is often operating off in their own world, right? They have no connection to the engineering team. If something changes from the design side, they might find out when the product lands on their desk, and now they have to change their test protocol. And the result of this, inevitably, is poor decision making across the organization. And this is not to blame any individual group. This is just how things are, right? Like if you're working in your own individual document, this ultimately drives bad decision making for all the reasons that I've listed here. So this leads to the idea of application lifecycle management. And what we mean by ALM application is not like an app like you have on your phone. The application means the ability to take a widget that you build and to prove it's fit for purpose to do something with it, right? We go back to that V model. Did we solve the problem we set out to solve? And so we've seen kind of four rough groups of organizations in their maturity and the efficiency gains that they see for this practice. And it starts with document-based work. Everything lives in a document. If I start building a new product, I take all those documents and I might copy them. Or I might start with clean sheet and write all new stuff. Traceability is fragile and it's manually enforced and checked. As organizations start to mature in this practice, they start by creating a system that pulls all the requirements in. There's now visibility across teams to those requirements. And as you mature in this phase, you start being able to curate a library of common requirements, which starts to facilitate reuse. So if I start building an iteration of a product, I'm able to take a bunch of requirements I used in the past and use them again in a systemic manner. And if I need to change a requirement, I only need to change it in one place because of the way I'm reusing and consuming those requirements across products. As the organization matures, this leads to the dynamic V model. Here's where we mostly get rid of those documents, right? This is where we now have risk, tests, test results, all in a system. Documents are now created from templates. So documents are now created from the work artifacts people build as they do their job. That means engineers have a huge reduction in the amount of time they spend doing what I like to call fonts and margins work. I don't think you're hiring your mechanical engineers to spend their time shepherding a Word document to make sure that the formatting of the text, the font of the text, and the margins and the colors align with your company style guide. the quality team. So this is a huge point. This is really where you start to see massive gains in efficiency. And then ultimately it matures into an ALM practice. You now have cyclical product releases with release management. You're now able to have complete visibility into what's going on across things. You move away from reviewing whole documents to now doing what's called item-based reviews, which means when something changes, you only need to review the things that change. You're not reviewing everything. You only need to review that small slice of things that changed. So if I take a product and I say, we're going to take this wrench and it's going to go from being a green wrench to a red wrench. Everything else about the wrench has stayed the same. So I don't need to retest that. I only need to look at the fact that the paint changed and do the tests associated with that paint change. I'm also able to see with clear visibility when things change, what that impacts across the whole organization. So I'm able to drive a change. If a requirement changes, I'm able to drive that change down into my PLM system so that engineers are able to quickly take that and work on CAD to assess that change. And we see huge efficiency really growing across the organization. And because all the data is now connected in a structured way, I'm really able to start modern tools like artificial intelligence to see absolutely incredible gains in efficiency. This is the summary of what we've really been hearing from a lot of people, where they've been expressing frustration with document-based ways of working, where they're trying to be more efficient, they're trying to get products to market faster, they're trying to operate with higher quality and greater compliance, but they're held back because of all the issues we've discussed. And these are the stages that we see as we help organizations go through this journey in order to be faster, be more agile, be more responsive and resilient to market changes. Are there any questions about this before I hand things over to Laura and we look at one way of moving away from document-based working? Very good. Laura, over to you.
Great. I'm going to go ahead and share my screen. I promise this one isn't my fault. It's still waiting for me to be able to share my screen. Okay. So this is Codebeamer. I have here customer requirements. Actually, let's go back to this. I really want to emphasize this V model that Robert pointed out, because Codebeamer is set up so that under the covers, everything is kind of connected like this. And anytime you want to go back and think about this V model, you can. In this picture, I have product requirements, system requirements, subsystem requirements, modular design, and design and build. And over here, I just have different levels of verification or testing. And what this is the ability to take a very, very high level idea of what you want to do and decompose that into different levels. And at each level, be able to say, yep, my product does this. So sometimes that's going to be regulations where you're going to go through and you're going to do the verification needed for that regulation. Sometimes it's going to be like subsystem requirements. Sometimes it's going to be software integration testing. But the point is, this is made so that when you make a change at one level, you can see what it's going to affect, and you're going to see what testing also needs to be redone. So you can be much more optimized by putting everything into this V model format, for lack of a better word. So I'm going to go over here to trackers. And these are going to be the same kind of ideas that we had for those different, what are they called? Parallelogram. Those pictures in the V model. We have customer requirements, we have hardware requirements, we have software requirements. Every single one of these is completely configurable in Codebeamer. This is just an example template that I'm using, but you can make this match what you need it to do. So going in here to customer requirements, we often work with customers that are very used to having this in doc managed systems. So this actually still looks like a document. We have our customer requirements. We have the ability to have pictures. We can have bullets. We can have numbered lists. We can have charts in here. It's very readable for a human being to be able to see what are these customer requirements. We also have the ability, if you're an Excel lover, is to kind of make it look more like a table view. And you can modify everything within this table view if you need to. So going back to our requirements, if you think about it, for each of these, they're individually managed. So I can go over here and I can see a bunch of metadata for each of these. I can individually go into one and I can see the world according to it. So I can see different hardware tasks that are related. I can see regulations that are related to it. I can see hardware requirements that are related to it, hardware test cases. I can see the history of it. If you think about the world when you're in a document-based view, you can see with like Microsoft Word or Excel, you can go through and you can see that it changed, but you're not going to see necessarily who changed it. What did they change? What time did they change it? What's the difference between the two? That's all built into Codebeamer. That's what you get by having this dynamically in a system. So going back to trackers, we can look at hardware requirements. That's going down one step in that V. And here we can see that this particular intuitive control panel has a few downstream references. One is architectural requirements, and we have some test cases. So being able to see the world from this particular tracker item lets us know where this came from, which is this hardware requirement or this product requirement, user-friendly control interface, and the downstream references. So you can see up and down that V model depending on where you are. So thinking about testing, being able to be sure that you did all of the testing work for a particular product is incredibly important. So if we think about this V model, being able to know that you did all of the testing you need to do for each one it's a challenge. How do you know that you created a test case for each one? How do you know what those test cases are? And how do you know if they all passed, they failed, they were actually run? So there's a lot of work to do whenever you're working on anything in here. If we go to our hardware requirements, as I said, Codebeamer is kind of built to lead you towards that direction so that you can know. So right here is where we can do test coverage. Codebeamer can inspect all of our hardware requirements and it can tell us what homework we have to do. So right here we have not covered, incomplete, not applicable, blocked, failed, partially passed, and passed. This lets us know exactly where we are with each of these. So I can see here I have something that's blocked, and I can go down here and I can see my test run was blocked, and that's why I'm not completely done with all of my work for my hardware requirements. So this is being able to define all of your hardware requirements, define all of your testing for them, and see where your testing is in your product lifecycle. So if we think about how would you do something like that in Excel, you would have a document like this where you would have your customer requirements. Again, this is not actually very readable. You can get the information here. You can see where you are. You can see how far you are in your life cycle. You can see your hardware requirements. You can see your test cases. But this doesn't give you the context of each one with each other. You're not really able to see that. You can reference the other ones. You can go through there, but you can't really just deep dive into a particular topic and know what's going on. With Codebeamer, you get that just by having them in this tool. Now you can export them. You can have at the end of every milestone or every release, you can have a Word document. If you need to have Word documents for something to send to a supplier, you can have a Word document. But you don't need to have all of the changes live in that Word document. The Word document is an export from Codebeamer. So let's go through what it's like to add a requirement. You can go ahead here. You can type in new requirement. Add details to this requirement and save. And it's as easy as that. Now, during different parts of your life cycle, you're going to be adding a lot of requirements. And then as time goes on, you're going to add less and less and less and less. But you always need to know, are you done with your work? Being able to have these statuses here lets you know there's still work to be done to review this requirement. Being able to go here and see, look, I have something that's not covered. I don't have all of my work done for particular tests for these hardware requirements. Here I can see I'm not covered. 5% aren't done. And if I open this up, we're going to go down here and we can see we're not covered. So things like this can be put in a dashboard so that people can really track where we're going for these product life cycles, for different milestones. I always have fun going somewhere and they'll be like, we have 90% of our tests passing. Like that would be in software. You want to, at different milestones of your software, you want to have different thresholds for when you feel like you're successful for that milestone. And sometimes it'll be like, oh, we have 90% of our tests are passing. But if you have 90% of something where you're only covered 15% of your product, that's not really 90%. What this gives you is a full idea of where you are with the testing for your product. Right now, I know that I'm like 71% test pass rate because I know that I'm not fully covered. This gives you a much better idea of how you're doing with your product. And if I were to think about how I would get that information from Excel, I just wouldn't. I would have someone in Excel pulling documents from many different places, putting them in there, and maybe once a week they would do the work to be able to publish it and give it to everyone else. Here we have it live because it's in this system. So if I want to go ahead and do the rest of my work here for this hardware requirement, I can go ahead here. I can say generate test case. It's instantly going to create my test case. Now I can go through here and I can update this test case. Right now, all it did was pull in the details of the other one. I can go through and I can add more details. And again, just like we had for our requirements, I can add links, I can add pictures, I can change my formatting, I can have bold, italics, everything that you would have in any like word processing document, you can have here with the test cases. So we can go ahead and save this. And we can do a new test run. This is a simple test run just to go through and execute this so I can run it. I can pass. And now if I go back to my hardware requirements, and I see where we are. Again, this is something that someone's probably going to be looking at once a day. You're going to have hundreds of people working on things, but you can see when things are covered, not covered. You can see our pass rate went up. This really lets you understand where you are and what work is necessary. So if we think about this, I just went through and I updated something in one release. We can do this for every single release we have in our system, meaning you're not only working on like the engine that's being used right now. You're not working on next year's engine. You're probably working on several different years. Like if you might be working on model year 26, model year 27, and model year 28. Whatever you're calling these release cycles, you're more likely working on more than one at a time. And when you need to make changes and you need to push them forward, in Codebeamer, you have the ability to have each of those. We have them show up over here as streams, but that's the ability to have different versions that you're working on at the same time. So if you imagine some new regulations came out in California for the year 2029, you would have all of the work that needs to be done so that you can be prepared for that regulation for 2029. But you're also going to be working on things for the model year 26, 27, and 28. When you make changes to those, you would have to make those changes go forward. If you lived in a document-based world, how would you do that? You would have these saved off where you would have like engine 2.0, engine 3.0. And then throughout your release cycles, you'd want to be able to see what something looked like at different milestones. So that's when you would have milestone 1, milestone 2, milestone 3. In Codebeamer, we have it built in so that you can save off everything at any particular time where we have baselines. And you can say, okay, this is what mine looked like at milestone 1. This is what mine looked like at that point in time. So you have something that is uneditable. You can go there and you can see everything that was in this tracker at this moment of time. But it can't be changed because that is the baseline that happened at that moment. That is the release of the product. With Codebeamer, you have that built into your system. If you're thinking about how you would do that in Excel, you would have so many documents in here. You would have someone who is in charge of taking the changes in one document and moving them forward to the other documents. They would be contacting everyone through Teams. They would be contacting them through Word, say, hey, did you update the document? Is this something that I need to move forward to the other things? Having that in Excel, in Word is completely possible. But now you have the added headache of somebody making sure that those changes propagated forward versus having that in a system where the engineers can look at it, they can see there was a change, and they can move that forward. So that's part of what makes it lovely to have a tool that's made for application lifecycle management versus doing all of that work in a document-based tool. So going back to our V model, we want to look at things and we want to know how do we have this set up in Codebeamer. We can see here that I have these linked in and this is flattened out. And what you can see here is I have this part of the V, and then I have this down here, design and build. This design and build really depends on what kind of requirements these are. So I have an example with hardware requirements. And each of these hardware requirements can actually link up to a particular wind chill part. So what we can see here is I clicked on one and I'm able to go straight to a part from a hardware requirement. I can look at this part, I can move it around, I can scroll down, I can see the information that I need to know from wind chill. Again, all of this is configurable. And I can actually go straight to that wind chill part. So if I'm a requirements engineer and I need to see more information about the part that has to do with this hardware, I can see it right here in wind chill. And if I were a mechanical engineer and I'm doing the stuff that I do in wind chill and I need to see more information about it, you also have a link just like this that goes right back to Codebeamer. So this is that V model flattened out. So these hardware requirements each have the ability to have these wind chill parts. And you're able to see exactly what is related to what with our traceability. One thing that we also have is the ability to do this with software. I think Robert was talking about how many months it took to be able to see what a change would be down to the software. And what we have in Codebeamer is also the ability to link software all the way up to your parts or all the way up to your products. So we have product requirements, software requirements, and stories. So you can do your agile work in here. And as you're working on things, you can check things in, commit them to your story. So you're doing your work and you have your SCM commits, and this can take you right to the line of code that actually was changed for that story. So being able to, again, have that full traceability from product requirements, we have hardware requirements, we have software requirements, we have the ability to link to software code, and we have the ability to link to hardware. So if you think about it and you have hardware and software working together, now you have the ability to make a software change that can then impact hardware, and you have full traceability between software and hardware. You don't have to use Codebeamer just for software. You don't have to use it just for hardware. You could work with something that's just like this, where you have like electrical and you have hardware. Usually those are two different groups that barely work together. Now you've put them into a tool that has that traceability between all of this. Do we have any questions from anything that I've shown so far? Robert, do you have any additional things to add? We can take a moment.
It looks like we have a couple of questions coming in from the chat. So this question's coming in from is it's the first time I see details about Codebeamer. Is this solution oriented to projects to develop new products and also maintain them? And the answer is yes to both. So as we discussed before, the idea of the circular information loop, it's about making things much more efficient in the development of new projects. But it's also, as you're maintaining a project, being able to take feedback from the field and give that easily back to the engineering team.
And another question is, do you have use cases where Codebeamer is used in engineering to order process? And Codebeamer is, in fact, used in that. I think sometimes we call it configure to order, where you're able to use a mechanism that will create essentially like a set of requirements for what needs to be built based on a bunch of configurations. That's something that could be an hour-long, lovely, fun topic on how you would implement that, but we do have customers doing that. And Codebeamer is like the strong horse in that, where all of those are maintained and easily created.
And with building kind of this this library of items where you can trace down from requirements through to parts that fulfill those requirements and designs. What this lets you do in some cases for our customer is even take that business model and potentially shift it a bit, right? We go from customized to order, engineer to order, configure to order, or just off the shelf ordering. By creating this reusability, we're effectively able to move the organization a bit more towards, there will always obviously be some engineering to order, but we're able to reuse previous designs that align with what we're doing. Maybe it's 80%, maybe it's 90%, but it's rare for an organization to get a truly novel request. Most requests are going to be a slight variation of the business the firm engages in. So you should be able to reuse a lot of things that you built previously for this new project. Laura, we
Do we
have
have any?
another question in the chat. The question is, how do I know that, like, how do I get visibility into the test results from the testing team as an engineer, right? So how do I take that feedback?
So in Codebeamer, we do have the ability for each type of requirement to have different tests. So here you can see I have hardware test cases and I have software test cases. So you can have all of the results for your testing stored in Codebeamer. I was able to walk you through one where we had it where you did this stuff in Codebeamer, but you can also have other testing tools update these test runs so that you can then see that in Codebeamer and you can see the test results. And then whether you're a hardware engineer, a software engineer, an electrical engineer, a mechanical engineer, if they're stored in Codebeamer, you have access to that. So the tests can be run in a separate tool and then pushed to Codebeamer to see the results. The tests also have the ability to have all of those different fields that I showed. You can upload attachments to the test results. Does that help answer this question?
Yes. Very good. Any other questions from the audience? All right. Well, that's it from us. Why don't we break for lunch a little early here?
Yep. Just so you know, there's a lot more we can do in Codebeamer. This was a high level. If you're interested in more topics, you know who to reach out to.
Great. Well, thank you, Robert. Thank you, Laura, very much for your time today. This was awesome. And just to remind everyone, this will be up on tristar.com shortly. And if you want to check out all of our past webinars, please visit our webinar replay library or our YouTube channel at TriStar PLM. So again, thanks everybody for their time, and we'll let you guys get off a few minutes early. So have a good rest of your week, everyone.